Hi everybody, good afternoon. Hope you had a good weekend. Um, Hi Cole, hi Sean. I got the comment stream here in front of me, so as usual, if you got any questions while we're talking today, put it in the comments. Hi Frankie. Okay, so I got a few announcements to make, a few things to bring to your attention, and one thing is I mentioned this last week, but I'm working on trying to get more access to the GIS lab so that you guys can go in there and work when you need to. And right now, I'm working on trying to get Tuesday afternoon from 1 to 3 o'clock. And if I'm successful, there'll be a sign-up sheet for that as well. And so stay posted. I'm working on it. In the meantime, do the best you can to get yourself outfitted with a Windows computer and install ArcGIS Pro on your Windows computer, and hopefully you are successful. But I am trying to get you guys more access. Okay. Hi Gracie. All right. What's next? There's something else I wanted to tell you. Oh yeah. Okay. Let's go to Sakai. All right. Here we are. All right, so I added a link here in the side bar on the Sakai page for YouTube Live. So you click on that. Page for YouTube Live. Oh, look at that. It opens up the live stream. Okay, so now you all know how to, the link to my live stream is always the same. But when we're meeting synchronously like this, you can, as one-stop shop, Sakai, click on the link and open up YouTube Live. Okay. What's next? Lessons for this week. I'm going to add to this as the week goes on. But one thing I'd like you to do, if you have ArcGIS, getting to know ArcGIS Pro 2nd edition, that's our textbook for the lecture. And if you have ArcGIS Pro installed on your own computer, there's a link here to go to this page where you can download the data for the tutorials in the textbook. So this is analogous to what we downloaded in lab last week for the laboratory workbook, except this is materials for the textbook, Getting to Know ArcGIS Pro 2nd edition. So it'll download an installation file and install a directory in your file structure in the Esri Press folder that has data for the tutorials in the chapter. So we're gonna use some of this data today. We're gonna walk through most of the high points in chapter 2 of the textbook, and so we'll get to that in a second. All right, what else I got here? So on tap for this week, in lab we want to complete lesson 2 in Smith et al., the project workbook, and we want to read and do exercises in chapter 2 of Law and Collins, which is Getting to Know ArcGIS Pro, the textbook. And as always, there'll be a link here to go to replays of lessons on YouTube. All right, so our class, the resources are building, and we're starting to gain some steam. All right, so let's keep it going. Okay, so again, if you have any questions while we're working here, put them in the comments. But I'm going to switch over to my desktop, and hopefully you can still hear me. That's weird. And I'm going to minimize this and minimize this, and I'm in ArcGIS Pro. All right. So, excuse me. So let me know if you can't hear me. I think I have all my mics set up correctly. How would you? I'll put that in the comments too. Let me know if you can't hear me. Actually, let me know if you can hear me. Okay. All right. So I'm going to go through the material in chapter 2 of the textbook, and there's 3 exercises. We'll try to get through 2A and 2B today, and maybe do 2C next time, or maybe just skip it all together. Here's a little disclaimer. I am not a huge fan of 3D GIS. I don't, for most situations, doesn't add too much, but it's neat. It can make really cool visuals, but I'm not sure they're really that useful for most situations. Anyway, I digress. All right. Okay, so what we're going to do is we're going to start a new project, and I'm going to call it Getting to Know ArcGIS Pro Chapter 2. This will probably give me an error. Oh yeah, because I already created the project. All right, you can do this. I already created the project, so I'll just open it. And there's nothing in this project right now. It's just got the map template. So so I know that this is, I wonder if I can make my, I'm going to work on that for next time, make my text larger. This could be hard for you guys to see. And I realize now that you can't even see it all. All right. All right, I think if I do that, nope, still some off the screen. Hold on. My monitor is super wide and wider than the live stream. There we go. Now you can see it all. Alright, so you can see my catalog pane over here, my contents pane over here, and my map pane in the middle. Okay, so what we're going to do is, let's see, how should we get started? Let's start with making, let me see if I can show you this. So I've downloaded the data files that go along with getting to know ArcGIS Pro, and they're installed here. And if we go into one of these folders, there's files. I know this is hard to see, hard for you guys to see, but what you have are files in here with the MXD extension, .mxd, and what that is these are self-contained map documents. They contain the map, the symbolism, the layers, and also all the data that go along for the map. And we're going to open up one of these, and we can go to Insert, Import Map, and then I'm just going to navigate to that folder as we press Getting the ArcGIS Pro World. Here it is, World Data. Okay, I'll click OK. And so you'll see that this imports There's 1, 2, 3, 4, 5, 6 layers. Some of them are turned off. And it imported all the symbolism, all the symbology for this map. All right, so that's one way that you can share map documents using these MXD files. And in the share menu, one of the options is to share the map, and that will create one of these map packages that you can share with other people. All right, another thing, and you've done this already, you can add folder connections so you don't have to go searching for stuff. So let's add a folder connection to this directory as well. Okay, so now if I click on that folder, there's the geodatabase that has it has a vector layer as a feature class of vector features showing the locations of cities, polygon showing countries, this longitude grid, and then it's also got a polygon layer for the oceans. And all of these things are already on our map. Okay, so let's turn off the cities. Let's turn on world population. And so now I got a question for you. I turned on that layer. See, it's off now. Now it's on. Why isn't it showing anything? Does anybody know? You say in the comments. Why is that not showing anything? So cities isn't checked. Right, Jasmine, cities isn't checked. But let's see if I click on cities. I need like 2 computers to do this. There we go. Cities. Now you see the cities. I turn off the cities. Turn on and off world populations down here, and nothing happens. Any ideas? Too much data. Gracie says too much data. Excuse me. Well, that can happen. You can have a situation where there's too much data and there's a lag in rendering. But okay, so here's an important lesson. In GIS, data is layered. Okay, and what's happening here is you have a layer above the world population data that's obscuring, it's blocking it. Okay, so here we go. It's the countries layer. So I'll turn countries off. Now I'll turn world population on. Boom, there it is. Okay. If I turn countries on, you see how that's blocking? So you can drag layers above. So I can drag world populations up here above countries, and now you'll always see it. If I drag cities down below world populations, now the world populations polygons, these country polygons, are obscuring things. So we don't want that. Okay, so it has to do with layering. Okay, let's see, what's next? So let's turn on, we'll turn off world population, turn off countries, turn off cities, and turn on air pollution by country. Okay, air pollution by country. And it's really hard, you know, when you look at this map, it's really hard to know what the colors are trying to communicate. All right, so let's take a closer look at this symbolism and see what our options are there. So we'll go to air pollution by country, and I'll click on there. And there's um, a a legend that's provided. So this tells us a little bit of information, and it says urban air pollution parts per million concentration. So red is greater than orange, is greater than yellow, is greater than green, and there's no data for some countries, Greenland, Antarctica, and some countries in Africa. And so maybe you can maybe that's natural to you, that when you're looking at a choropleth map like this, that's what these are called, choropleths, where colors encode some feature of the map, in this case air pollution. Maybe it makes sense that red is higher than green. But in general, it may not be a good idea to use rainbow color schemes. Anybody think of a better way to use visual, color, light, dark, to communicate the intensity of something? Let's go over here, and to change the symbology on a layer on your map, right click and then select symbology, and then this menu pops up. So if we look at the options, and on ArcGIS Online you have similar options, but you get them a little bit way. So the options are single symbol, right? So this will render all the features on that layer as the same color. All right. You can do unique values, and let's see what happens here. So here every country is a different color because every country has a different CMI country code. Okay. You can do graduated colors, and that's what was just happening. And then when you do that, you have some choices to make. So here, one thing you can specify is how you want the different categories to be colored. Well, let's look at the color scheme first. Oftentimes, instead of using rainbow colors or more than one color, it's much better just to pick one color, and that varies in tone or intensity. So blues, greens, or even grays. Okay, and then you can always great, it froze on me. There we go. But let's do the reverse. Here black is higher than white. And let's do blue, because I like that. Okay. And the field. Keeps getting stuck on me. Is there we go. Now change the color. Hold on, almost got it. Come on. The computer's not responsive. There we go. Okay, so here I'm visualizing the a column in my attribute table called PM10 for particulate material of 10 microns or smaller, and white is not a lot of pollution, Dark blue is a lot of pollution, and the units are in parts per million. Okay. Then you have different ways that you can create these categories. So you can select how many classes you want. Maybe you want more divisions. You can increase this number. You could manually set the interval that you want to have for your different classes. You can use quartiles. You could do the default that was used here is natural breaks. So it looks at all your data, and what it does is it looks for natural clusters in your data, and then it assigns points in your data to the groups based on those natural clustering that occurs. So one thing about using this method called natural breaks is the range of values isn't uniform. So for example, I mean, look at that. It's the upper value of the lowest category is 100, and or minus a negative number. So there's a problem there. So you go from 0 to 50, and then from 0 to 60, and then from 60 to 125, and then it doubles again to 250. So they're not uniform. The classes that aren't uniform in size. Okay. So anyways, graduated symbology like this allows you to make choropleth maps where the color communicates the intensity, in this case the intensity of air pollution, which is one of the features, or one of the attributes that's attached to each of our features, each of our countries in this case. All right. Let's see, what else is in this chapter? So let's turn off air pollution. Let's turn on cities and countries again. Okay, so let's say you wanted to find the city on this map that has the largest population, and let's look at the symbology that's being used here. Okay, and the symbology that's being used here are graduated symbols. So instead of colors, instead of there being different colors to show the different intensity of different features, here there's circles, and those circles are larger if the magnitude of the attribute being visualized is larger. So in this case, what you're seeing are each dot is at the location of a different city, and the size of the dot communicates how many people live in that city. Okay, so the size of the symbol itself is communicating something about your map. And so let's say you wanted to find the 5 largest cities in this map. How could you go about doing that? Well, I guess what you could do is you could say, well, this looks like a big city, Moscow, population 10 million. What's this? New York City, population 8 million. What's this? Tokyo. So you could go around the map and click on the symbols that you think are big, and you could try to like find the 5 biggest cities in that way. That's not a good strategy at all. Okay, so here's what you can do instead. You can remember that the sizes of these dots are one of the columns in your attribute table. So you can open up your attribute table and explore things there. Okay, so we'll do that. We'll go over to cities, the cities layer, right click. Let's view the attribute table. You can undock these things too. Let's say I want to undock the cities. I can just drag that up here, and I can undock the attribute table. And if I want to dock it again, If I click on it and drag, this little thing comes up where you can select, where on the screen you want to dock that table. Let's put it back down at the bottom. Let's make it a little smaller. Okay. So how can you find the biggest cities? Well, the population is in this column called population. So I'll go over there, right click on it, and I'll do sort descending. So I just sorted all the rows, each row is a different city, by population descending. And now if I go over here to this gray box along the side, if I click on one of these, like let's say I want to know where Buenos Aires is, click on this box and it gets highlighted on the map. Mumbai gets highlighted on the map. Mexico City gets highlighted on the map. And I can hold down Shift and select multiple. I'm holding down Shift and I'm selecting multiple rows. So I pick the first 5 and they all get illuminated on the map. Okay. So this one way this is a more efficient way to find features on your map, to highlight features on your map that have certain characteristics. Go to the attribute table and select rows in the attribute table, and when you do that, the feature that corresponds to that row gets highlighted on the map. Let's clear all these selections. So I click this button up here, clear the selections. Let me show you something else. Let's say I'll turn on world population, cities, and air pollution. And now I'm just going to click on a feature here. Using the select tool here, I'm going to click on the United States. And this little box pops up. And what this is showing is that the region I selected on my map actually has features on multiple layers, and it's showing that. There's a feature on the countries layer, a feature in the United States layer, or the world population layer, and a feature on the air pollution layer. So what do I want to look at? I can pick which layer I want to select from. Okay. Let's see. All right. Let's explore this way of symbolizing magnitude. Let me close that. Let me see your map. Actually, before you do that, let's turn off some of these layers. Okay. And zoom out, zoom in. This is, when I look at this map right now, I can tell that it's using some sort of Mercator map projection, because all the grid lines are rectangles, perfect rectangles. All right, so you can see that there's distortions in shape and distortions in area. Let's go click on this and look at the properties of this layer. So how can you tell what projection is being used? You can go to the source tab under properties, and then down here there's a drop down for spatial reference. And if you look at that, you'll see that this layer, the air pollution by countries, using a projected coordinate system of Web Mercator. Okay, so it is using a Mercator projection. If we go up to, let's rename this. I double click on that. So my map is called layers. Let's call it world. All right, because it's showing the world. And right click on that, properties, and let's go to coordinate system. So what is our map using? Well, our map is using WGS 1984 for the geographic coordinate system, but there's no projected coordinate system specified. And so what's happening here is the map is being rendered using a default projection on the fly. All right, but let's before we move on, let's just play around with some different projections and see how that changes your map. All right. So we'll do, let's see, how about when you're looking for, let's first look for projections that are good for West Virginia. So one thing you can do is you can do a spatial filter. So I'll click here and do set spatial filter, and let me zoom in here to the area of the world where West Virginia is. Okay, and now I'll do I'll filter, do a spatial filter by the current visible extent of the map. Right there, click apply. And so let's see what we got. Well, let's do NAD 1983. Let's see what we get here. Okay, so that looks like it's pretty reasonable rendering of this area of the United States. Let's zoom out. Let's try, let's search for an Albers projection. Let's look at this Albers projection for Alaska. So here's a projection which is designed to work well for Alaska, to render Alaska so that its shape and its area and direction and all that are true for the area of Alaska. But if you look at other areas of the world, it's horrible. I mean, look at Africa. This projection would be horrible for a 2D map of Africa. Or sorry, that's South America, of Africa. Let's see what else we got. Let's search for so here's a projection which is designed to show the North Pole, correctly render features that have the right size, shape, and distances and directions relative to the North Pole. But this projection would be horrible for studying Mexico because it's so distorted. All right, so I just want to show you that just a few examples. And let's go back to WGS. All right, so we're back where we started. Okay, so let's turn on the cities layer again, and let's take a look at the symbolism that we can use for cities. So these are using graduated symbols. And we have some options here. We can again set the intervals, natural breaks. We can set the minimum and maximum size of the circles, set the number of classes, and so you can control a lot. And you can also change, if you click here, the template. So maybe you don't want blue circles, maybe you want red triangles. You could do that. Okay, maybe you don't want them to be red, maybe you want them to be green. You can change the color. Maybe you don't want them to have an outline. Turn off the outline. And the realm of possibilities is basically endless. But symbolism is really important when you're designing maps. Okay, so I guess one thing that I will say is when you're applying symbology to the features on your maps, there'll usually be a default, a default number of classes, a default color scheme, and how often is the default the best choice? Probably never. It's something that you want to spend time with, the symbology used on a map. Okay, well, maybe we want to add to this map, what these symbols represent. They're cities. We want to see those cities' names. So we can right-click on the cities layer, and we can go to Label, and it turns on a label for each of these symbols, and that's really busy, isn't it? Maybe we don't like what's going on there, so we go to the label properties, right-click label properties, and we can select, and here the default actually was good. The thing that's being expressed, being shown, is the city name, and that's already here. But maybe instead of the city name, maybe what we want to show is the object ID. I don't know why you'd want to do this, but now all the city names have been changed to a different value in the attribute table, but that doesn't make any sense. Okay, and this is really busy. It's hard to see. I mean, if we zoom in, it's good. If we zoom in, the font changes, and you can change all that. You can change the size of the font and all that. Maybe you want, this to be bigger font. All right, and now it's really going to be bad if we zoom out. Okay, a lot of the data, a lot of the labels are even missing here, and so this isn't good. So one thing you can do is in the ribbon up here, the ribbon is I don't know, maybe we'll just call it the menu up on the top of the page. It's contextual. I think that's the name that we would use for this. What that means is the options that appear at the top of the page, on the top of the window, depend on what you're doing at that time. And so if you're working with labels, let's go back here, notice that the ribbon has changed, so there's these contextual options, and one of them is labeling. Okay, and so what you can do is here in this box that says in beyond or out beyond, you can specify that you don't want your labels to turn on if you're out beyond a certain scale. All right. So here's an important concept, and the concept of map scale. Okay, so scale is, here, let me turn this on. I'll write on the whiteboard here. Scale is represented in the bottom of the map as a ratio, and so there'll be a number like 1 to 1,000. And what this is telling you is that what you're doing here is you're representing things that are large on a map that's small, and so what this is telling you, if it says the scale is 1 to 1,000, it's saying one unit of measurement on your map is equal to 1,000 of those units of measurement in the real world. So if the units are inches, 1 inch on your map is equal to 1,000 inches in the real world. So if that number on the right hand side of this ratio gets really, really big, that's like a map where you're zoomed out a tremendous amount. And we call that a large scale map. All right. And if that number is small, then that means you're zoomed in really well and far, and that's called a small scale map. Okay. So if this was 1 to 100,000, this would be small scale. Oops, sorry. Large scale. And small scale. And I guess the way to think about that, you're like, well, why is the large number small scale and the small number large scale? I think the best way, maybe you can think about it as a ratio or a fraction. You know, if you have 1 over 100, that's a bigger number than 1 over 1,000. 1 over 1,000 is a smaller number than 1 over 100. Anyway, in ArcGIS Pro, at the bottom of the window, there's going to be the current scale of the map, and you can change it. Say I want to, well, I zoomed into an ocean. Here, I'll center on Africa, and then zoom in, or zoom out. And so let's see, where about do the labels, at about 1 to 20 million, the labels look really well. So if you're in, really good. So if you're there or in further, we want to see the labels. But if we're out further, we want the labels to disappear because it just starts to become a jumbled mess. And that's where you can use this out beyond feature. So I can go up here and I can select there, 1 to 20 million. And now if I'm zoomed out really far, the labels disappear. But if I zoom in, when I cross that scale of 1 to 20 million, almost there, the labels appear. I zoom out, they disappear. Zoom in, they appear. Okay, so that's a pretty cool feature. All right, let's see, what else? So let's take a look at, there's a tool built into ArcGIS Pro, and it has to do with measuring. You can use this tool to measure distances and areas. And so let me show you this tool, and then give you a warning about using these tools. All right. So let's zoom in here to the United States. And here's New York. Here's Los Angeles. Let's measure the distance between New York and Los Angeles. So in the Maps tab, go over here to Inquiry. There's a tool for measuring, and we'll measure distance. We'll go. Oh, look at that. There's no there's no projection applied. Hold on. Let's apply. All right, so I applied a funky projection to this map, and then I'm going to measure the distance from Los Angeles to New York. Okay, and what you're noticing here is, well, that's weird. It's not a straight line. Well, what it's measuring is I have it set up here to measure geodesic distance. So it's compensating for the fact that what you're trying to do is measure the distance between 2 points on a curved surface, the surface of the Earth. Typically, when you're using a map, what you're measuring is try this. Search for hold on, I'm trying to find my projection. Yeah, let's do this one. This is good for West Virginia. Okay, so this is one of those universal transverse Mercator projections, and so what I get is come back here. Sorry, that line's not showing up too well. So what I'm getting is if you're measuring the point-to-point distance on a map, you'll get different distances depending on your projected coordinate system, and that could be a big problem. So you have to be aware of this, and you got to know, like, you know, at what scale is your map going to be an accurate reflection of the real world. At what scale are distances going to be true, direction is going to be true, that sort of thing. And if you have a map that's a local map, you know, let's say state level, state size, or larger scale, meaning closer in, then you can pick a projection that's good for that area of the globe. On maps that show the entire world, forget about it. You're not going to, the best you can do is pick a projection where distances are true from a single point to any other point on the map. That's the best you can do. So any other distance between 2 points is not going to be a true distance. So it's just something to be aware of. Do maps tell the truth? Some partial truth. Do maps lie? Yes. Maps lie all the time. Okay. So we'll call it a day there. Do you guys have any questions before we hang up here? So we got through most of chapter 2, and the last part is, well, how do you, I already showed you that, it's where we began. Let's say you make a map and you want to share it. You can use the share tab, and you can save your map as one of these MXD files, and you could email it to your friend, and your friend would be able to open that, and it would have all the layers, all the symbolism, all the symbology, and all the data that's being shown, all in a nice, neat, compact package. Okay. So let's keep that in mind. All right. Then I will see you guys on Wednesday, and in the meantime, I'm still working on trying to get, trying to figure out how I can get you more access to the computer lab. All right. So stay tuned, and I'll talk to you later.